Here I'm going to talk about the difference between the x-bar distribution and the x distribution, and I'm going to show you two examples by drawing them out on these normal curves that I've constructed. And so the variable that we're discussing here is the average miles per gallon of a single car, and so I'm going to let that be represented by x. I know that the population is normally distributed with mu equal to 27 and sigma equal to 3. And so I can use that information to construct the normal distribution with this number line. And so keep in mind that each one of the values on this number line represent the average miles per gallon of a single car. Before I do an example, let me talk about the x-bar distribution. The main difference with the x-bar distribution is that the values on your number line are now representing sample means. And specifically for this example, we're looking at samples of size 60. And so data values on this number line are sample means, while data values on this number line are just the average miles per gallon for one car, so they're not sample means. And so notice that the x-bar distribution has a lot less spread or a smaller standard deviation, and so you can tell that by looking at the last numbers and the largest numbers, or the smallest and the largest values on the normal distributions. And so here, this makes sense because you would expect an average of 60 values to be a lot closer to your expected value than you would just one value at random, right? And so it makes sense that there's a lot less spread in the x-bar distribution. So now let's talk about how to find probabilities for these things. And so let's say I want to find the probability that a single car chosen at random has an average MPG greater than 31 miles per gallon. Then I'm going to use the normal distribution that corresponds to single data values. And so that's going to be this first distribution that I have here. So I'm going to look for the probability that one data value is less than 31. And so on the curve, this will look something like this. So I'm looking for this area, right? If I use a TI-83, then I can use my normal CDF function. Negative 100,000 is a safe bet for the majority of the distributions that we work with when we're looking for probabilities less than a value. And then here my maximum value is going to be the 31. And then my mean and standard deviation, well, I should use the mean and standard deviation from the curve that I'm using, right? So I'm going to have 27 and 3. If I want to find the probability that the sample mean of 60 cars is less than 26.5 miles per gallon, then my probability notation, rather than having x, I'm looking for the probability that x bar is less than 26.5, which means I should use the distribution that corresponds to samples of size 60, which is the second distribution that I've drawn here. I'm still going to use the normal CDF function. And so on this curve, this would look something like this here. And so a minimum value of negative 100,000 will work, a maximum value of 26.5, and then the mean and standard deviation should again correspond to the curve that I'm using. The mean is still 27, and my standard deviation this time is sigma sub x bar. And so I should have 0.3873.